discussion about the wave, how we represented psi as a complex vector psi, है ना? Psi that psi star is a psi square जो है, it will give us the intensity of the wave. The way traditionally आप पढ़ते आए हैं, you might have studied in Young's double slit experiment that when two light beams interfere, they may interfere constructively or so that impression is being seen on the screen. And if we want to measure the intensity, you might have studied the optics, I is equal to I naught square by intensity is proportional to square of this thing, I naught square. The intensity of the electromagnetic wave or I, light. अब वही है उसी का जो यहाँ हमारे पास एनालॉग है, टॉक ऑफ साई स्क्वायर. So it's basically जो matter waves है, when we said that they also have particle as well as wave character. So how can we see their impression on a screen? For example, two electron beams are coming through two pinholes. Still we will get a intensity pattern out here, है ना? The way अब ये है कि sometimes even if you just close one of the pinholes, still एक pinhole से जाएंगे ना, still we will get intensity pattern. So the moment we decrease this hole कि आप shrink करोगे, तो उतना हमारा intensity pattern will become fuzzier. It will not be that clean. जो हमको ये कह रहा है कि the particle and the wave aspects come in the conjugate thing. So if you concentrate on the particle aspects of the thing, the wave particle का impression थोड़ा it becomes dim. If you only concentrate on the wave particle aspect of that, for example, जो भी हमारे पास है, electrons है, protons है, जो भी है. Got a point. So अब ये है कि how can we represent this wave psi? If we said that we have a complex representation of psi, this psi can be represented as, अगर हम इसको in terms of we did some amount of discussion previously also, so, but to summarize it, psi of xt means this wave function. It's not the way, for example, in classical mechanics, we have a notion of particle moving from point A to point B under the influence of force, है ना? यहाँ से जो न्यूटन्स लॉ है, यहाँ से यहाँ तक particle, the trajectory is clean, है ना? हमको पता है 5 मिनट के बाद यहाँ होगा, 7 seconds के बाद यहाँ होगा, जो है force law, कितने न्यूटन. But यहाँ it's not particle, it's this psi. And psi has the characteristics of both wave as well as, and उसकी जो हमने एक analogy ली थी, that was sort of जो standing wave है ना हमारे पास ऐसे, यहाँ से एक forward wave आती है, backward wave आती है ना? उससे where the waves interfere maximum, तो वहाँ node आएगा, where they interfere they will be. So in the same way जो हमारे पास waves हैं, they will also interfere. दो electrons हैं या individual electrons हैं, so it's also a mix of particle and waves. Where they will interfere maximum, we say the probability of finding the electron is there or particle is there. ठीक है? This is the way. Still it's not that the idea is bit more abstract. हम कहते हैं कि वहाँ पर हमको particle मिलेगा. But even though here we have a confined wave between two strings, classical wave. It's longitudinal wave जो भी है, मत जो ये matter waves हैं, they are open-ended. So in a given region of space, these continuously interfere with each other. ठीक है? तो अब हमारे पास क्वेश्चन ये है कि two waves psi1 and psi2 they superpose. For example, yesterday I said psi1 and psi2 can superpose. So ऐसे हैं हम कह देंगे ना psi1. So जो इनका intensity pattern है, it will not be like this. Collective intensity, it will not be like this. It will not be like this. It will be rather this like this, because once they are going to interfere, it will be like this, because the two waves are interfering, and this is the amplitude of the superposed wave which is in consideration. अब ये है कि फॉर एग्जाम्पल इफ यू टेक वन ऑफ द वेव्स फॉर एग्जाम्पल एज psi1 लेंगे हम एज एन एनालॉजी इन टर्म्स ऑफ because we are treating it as a complex wave e to the complex wave में ये है ना e to the iota kx है ना for example k is the propagation k is 2 pi by 2 pi means इस 2 pi में wavelength number of wavelengths in these 2 pi's अब ये अगर complex wave है ये भी तो आएगा ना you can say it's cos of kx plus iota sin kx है ना so this wave तो इसमें cos wave भी है cos wave like you can say एक ऐसे है एक है ना so this pictorially at least graphically it embeds in it a sort of wave complex wave. Now we are representing this psi, this evolution of wave function, which is sort of this intensity was given by this probability amplitude. Psi conjugate हमको दे रहा था. तो अब ये अगर if you represent it by this wave, it is for iota kx minus omega t. So now you are trying to see how two waves are going to interfere for the simplest cases. It's maybe psi1 plus psi2 plus psi m. ठीक है जो भी है. So, but if we in a simple case take it psi1 इसका ये propagation आएगा तो it will be propagating towards increasing x. जिस हम यहाँ करते हैं stationary wave है ना we do it pluck it here ये forward ये आएगा when it strikes here it comes back due to boundary conditions तो backward ये आएगा. In the same we are going to take it is towards increasing x. The other जो हमारे पास आएगा psi2x t it will be minus it will be iota since k है propagation to forward तो जब वापस आएगा तो this k will change into minus k minus. So these can be two waves which are supposed to get interfered and they are not they are having properties of waves as well as particles and जो energy exchange होगा इनका that will be a discrete amount h2 जो हम कहते हैं ठीक है those waves that will not be continuous. So if we assume it like this and initial values हम for example लेंगे psi1 x of 0. X of 0 means at time 0 the wave is going to begin है ना start p जिस तरह initial value find the initial value the body has beginning started to start किया है तो if psi1 x 0 it's not body here it's wave psi which represents a particular electron proton photon जो भी है whatever which represent rather we say it represents a quantum particle quantum state. अब state is psi is the unique mixture of particle as well as wave properties. So psi1 x is and psi2 x will be so at time t is equal to 0 है ना t will be 0 here and t will be 0 here so it will be b equal to minus iota kx fine. तो अब यहाँ तक ये है so in your original classes you can also represent in terms of we can just close the door you can also represent it like ये है ना सर्कुलर वेव की तरह है ना cos of kx plus iota sin kx cos of kx minus iota sin kx minus sin will cancel ठीक है कैन या इसको हम करेंगे so we can represent it like जिस तरह सर्कुलर वेव को रिप्रेजेंट करते हैं in terms of cos and sin functions that's the point where we can represent a and b को हम ऐसे रिप्रेजेंट कर सकते हैं. So if we will just see it that way or we are going to see it as how can represent them as plane waves. अब इस plane waves का हम we are going to see its propagation. So we will not concentrate on y and Z. We can also take a three-dimensional wave, but we'll see the propagation of superposed waves कैसे आएगी. And we're going to consider this propagation along kx, ky, k and z will be suppressed. We're only concentrating on one-dimensional psi का propagation क्या आएगा, superposed. So what will it be? So in the original sense of the word, psi will be psi of. So it will be basically psi r. R is basically x, y, and z and t. इसका space evolution along x, y, z and time is basically so it will be a e to the power iota k dot x plus k dot y plus k dot z minus omega t. So k dot y is equal to k dot z is equal to 0. Okay, so that's it. And kx can be equivalent to plus minus k. So it can propagation may be forward or backward. That's it. अब इसमें ये है कि if we want to represent, since we have started with complex wave, but it is possible we will start with the real wave. कैसे? For example, for a particular value of, for example, forward, क्योंकि यहाँ एक है ना plus, दूसरा क्या है? This is one is plus and this is minus. So once they will superpose, it will be psi 1 x plus psi 2 x. Sometimes this psi 1 x I k x plus e to the minus I k x क्या आएगा? ये आएगा cos of k x plus iota sin x. Cos of k x minus iota sin k x. This and this will. So it will be sort of 2 cos a x. So you can have, even though they are complex waves, we can, for certain initial conditions where this at time t is equal to 0, it will be a good approximation as if it's a real wave. But for a particular boundary condition, not general xt. But if we start with xt, तभी तो यहाँ ये वाला हमने 0 लिया ना, otherwise we cannot take it 0. So for a particular, even though we say psi is a complex wave, but for a typical value of a wave function psi starting at rest, it will mimic or it will have a solution of as if two real waves are superposing. ठीक है? So this is what we are doing. So if that is the way, अगर ऐसी बात है, then you can represent the psi of x 0. So it can be sin iota sin x kx भी cancel हो जाएगा. We can write it as cos of kx. So it's basically plus so sin x will determines future behavior of waves unity. Why unity? Because we have started at some definite point. At some definite point, the origin से हमने start किया. The value of psi x 0 at time t. We started how the wave function is going to evolve, or two superposed waves are going to just evolve in time. Evolve, you can see that's better word. अब ये understanding लेते हुए we are going to see, so the actual wave may be more complicated, क्योंकि अगर उसमें हम time भी लेंगे ना t1 t2, तो दो superposed waves का कैसे हम लेंगे, how they are going to interfere, है ना, with respect to space and time. But हमने कहा कि in realistic, क्योंकि हमारी we are being used to real waves, so it can mimic it can have a solution of a real wave. अब ये है कि Now the point is how these wave packets, which you might have studied in your earlier classes, where do uncertainty relations come? Where do uncertainty relations, और जो मैंने अभी कहा था complementarity. Once we are going to make this pinhole smaller, our wave impressions on the screen, we are not able to observe them. Our observation of designing an experiment, whether we want to observe the wave aspect or the particle aspect, it comes in inverse relation. If we concentrate an instrument, उसमें हम wave aspect measure करना कोशिश करेंगे, उसी we cannot measure the particle aspects that cleanly or vice versa. अब इस चीज को हम कैसे करेंगे? We want to see it if, for example, an electron or matter waves in general, they are made up of sort of wave packets. Wave packets means acid. So these are continuously interfering, and where the interference or superposition is maximum, हम कहते हैं wave spread is maximum. Wave packets का concentration वहां पर है. उसी दूसरी जबान में हम कहते हैं we are saying the particle is supposed to be there. When the particle is not there, we can see mimic. Wave spread is there, maximum concentration wave का एक जगह. हम कहते हैं electron is there. So this is the way we see it. अब ये है कि wave packets and how can quantify that sort of uncertainty, which we are going to study in detail जब हम uncertainty relations में आएंगे. So here we will have a brief graphically or pictorially हम इसको कैसे we will have a feel of it. And one thing is कि we will have a feel of it in terms of the way we will like to study classical जो हमारा intuition है. क्लासिकल इंट्यूशन क्या है? हमारा सिंपल पता है, यहाँ पार्टिकल है, whether the particle is electron, whether you are me, duster, universe, planet, है ना, हमको पता है यहाँ से यहाँ जाएगा. 5 न्यूटन फोर्स लगाऊंगी, ये 5 मीटर चलेगा, ठीक है. ये हमारा पार्टिकल का एक ठोस है, it is here, a definite point in space. But when we have waves function psi, we have a थोड़ा सा हमारी लैंग्वेज थोड़ी सी obtuse हो, थोड़ी ambiguous लैंग्वेज होती है. Say that it's a combination of wave and particles, because wave is something which spreads. Particle का wave delocalizes, particle localizes. So it's mixture of both. Where the waves superpose maximum, interference maximum है. The analogy is like this. Even though this analogy is classical analogy, because if the world is ultimately quantum, we have to derive classical mechanics from quantum mechanics. But to make, since we are used, अभी तक आप you are used to classical intuition, तभी हम ये exercise कर रहे हैं कि that we want to understand these wave packets also in terms of classical particles, and that ultimate test has to be some experimental or experimentation. How the wave functions evolves vis-a-vis time, or the superposed waves evolve. कितने टाइम के बाद हमने वहां देखा जहां स्प्रेड वेव स्प्रेड मैक्सिमम, फिर कम है, फिर मैक्सिमम है, ठीक है. सो वी हैव टू कैलकुलेट इट द वे वी डू कैलकुलेट क्लासिकली. पार्टिकल कहां से कहां गया, यहां वो कैलकुलेट करना है साई फंक्शन कहां से कहां मैक्सिमम और मिनिमम है, और मैक्सिमम और मिनिमम के आसपास कहां है, यही तो काम करना है. सो वी आर गोइंग टू हैव ए क्लासिकल इंट्यूशन का, वी आर गोइंग टू लेटर देन वी विल बी यूज्ड टू क्वांटम इंट्यूशन. तो हमको इसकी जरूरत नहीं है. बट सिंस वी हैव बीन यूज्ड टू क्लासिकल इंट्यूशन, वी विल ट्राई टू सी हाउ इट कम्स क्लोजर टू द दिस थिंग क्लासिकल इंट्यूशन ऑफ फाइंडिंग waves have spread where its maximum will sit as if the particle is there. So this is the point. तो हमारे पास जो इक्वेशन है, सो इट्स लाइक दिस, जो हमारे पास ये है de Broglie wave है ना, k is equal to 2 pi by lambda, p is equal to mv है ना, lambda is equal to h over mv. So this equation is required. अब ये जो हमारे पास before we are going to just actually do it, we are going to use some techniques in mathematics जो आपने पढ़ा है Fourier analysis. You have heard Fourier analysis. So any book mathematical physics या थोड़ा उसको देखना Rifkin की है ना? Hassan there are many books, but it's basically how जो wave है ना, जिस आपने AC/DC पढ़ा होगा ना, two waves are going to interfere. If they are going to have the same value, same amplitude, है ना, तो maximum हो जाएगा. So it will be maximum interference. अब ये एक का कम होगा, दूसरे का ज्यादा होगा, एक वेव ऐसी होगी, है ना, दूसरी ऐसी होगी. How they are going to superpose? So it becomes a more complicated problem. इसको कहते हैं Fourier wavelet theory also. Now the problem is how we can translate this superposition of two wave functions, sine and psi 1 plus psi 2, in terms of this thing, how the waves superpose, है ना? तो we will take जो general theory है हमारी, उसी को हम कहते हैं Fourier analysis. It's a separate branch. You might study it more and more in later classes. Fourier. There's a theorem also to it. How we can add these waves in the general sense. अब हमारे पास if we want to जो ये psi है, we are going to represent it in terms of Fourier waves. तो psi जो हमारे पास है in terms of हम कहते हैं localized, the word we are going to use localized wave packets for superposition of plane waves of different wave number, है ना, उसी को हम कहते हैं we are going to use Fourier analysis, है ना, localized wave packets, ठीक है, उनका superposition of plane waves, ठीक है, we are not saying the particles, हम कहते हैं localized wave packets for superposition of different wave numbers. वो मैं कहता different ना frequency different होगी, किसी की कुछ होगी, किसी को ज़्यादा होगी. How they are going to interfere, है ना? अगर ज़्यादा फेज होगा तो एक वेव आगे ही जाएगी, अगर कम फेज होगा तो लैग करेगी, है ना? These are different subtleties. So we are going to use a technique in mathematics to that. So we are not going to study this technique, हम उसको सिर्फ यूज करेंगे, ठीक है, as a symbolism. Since we are starting symbolism में हम ऐसे करते हैं. So how do you use? हम कहते हैं we are going to see it. जो हमारा psi of x0, so we are trying to see the initial wave at time t is equal to 0, wave function psi. So we can represent it as minus infinity plus infinity means can the boundary, the wave starts from somewhere in the space, we don't have that. So ये psi है, psi को हम in terms of propagation represent करेंगे. Psi is the state, phi is the in terms of propagation. We are going to represent it like this, dkx, where phi and psi are related. When phi and psi are, तो कोई भी state psi, we are going to represent it in terms of phi. Phi में k आएगा, propagation vector आएगा 2 pi by lambda. So इसका inverse relation है. If you want to write psi in terms of phi, we can also write, इसको यहाँ लाएंगे, so we can write it as, आप यहाँ थोड़ा सा you don't integral से आप sometimes you fear minus infinity plus infinity क्या आ गया. It's like the way you solve definite integrals and indefinite integrals. An integral can take value differently, and integral can take value in. So later we can also specify it. So if you want to have phi, इसका Fourier inverse phi को in terms of यहाँ आएगा, minus आएगा, we can also write it as so इसी को हम कहते हैं कि you convert an integral into its inverse way. फाइव को है ना यहाँ माइनस एक्स का यहाँ प्लस एक्स। सो यू वांट टू कन्वर्ट a space into its inverse space and vice versa, इसको हम ambiguous space भी कहते हैं, ठीक है। this is a technique how we can relate psi with phi। इनवर्स में phi can be represented by psi, but यहाँ माइनस का फैक्टर आएगा। दिस इज द थिंग। अब ये है कि हम क्या करेंगे, under very general conditions हमको basically you have to satisfy the total intensity of the wave function psi ऐसे for ये psi square for this formula and this formula। So if I use the Mukki equation 2.10, so we have to see how this equation 2.10 and 11 how we have to see the intensity of the wave psi x square where it's going to spread, intensity spread। जैसे आप यहाँ आते हैं ना, टू लाइट वेव्स कहाँ इंटरफेयर करते हैं ऑन द स्क्रीन, वहाँ इंटेंसिटी निकालते हैं आई नॉट स्क्वायर बाय 4 है ना, यहाँ इंटेंसिटी कहाँ मिक्सअप, सो इट्स डिपेंडेड ऑन दिस वाई साई फंक्शन साइज वेयर द स्क्वायर ऑफ द एम्पलीट्यूड, इसको हम कहते हैं। अब स्क्वायर ऑफ द एम्पलीट्यूड ऑफ द wave function psi, and psi represents the state, quantum state, ठीक है। So this is it। अब ये हम what we are going to say is that we now assume that phi is a phi kx is a real positive function and its shape is similar to, I'll write a diagram first then we just try to explain। हम कहेंगे now we are going to represent the relationship of phi and psi। Psi is the state, phi is the propagation। Psi को in terms of x and phi को in terms of k graphically at 2 points। So we are going to write it in terms of, later going to see it in terms of some statistical mean variable। कोई मैक्सिमम लेंगे, मैक्सिमम से लेफ्ट हैंड साइड और मैक्सिमम से वेयर द फंक्शन का वैल्यू मैक्सिमम आएगा, ठीक है। वेयर द लोकलाइज्ड वेव पैकेट हैज द मैक्सिमम स्प्रेड, एक वो उसके इस साइड और उसके मीन ऑफ दैट स्प्रेड वेयर इट्स मैक्सिमम वैल्यू, उसका मिनिमम की तरफ कितना होगा और मैक्सिमम की तरफ कितना होगा। दैट विल बी ग्राफिकली रिप्रेजेंट फॉर अस हाउ द वेव फंक्शन का एवोल्यूशन क्या होगा। So it will be, if you want to represent it in terms of this thing, so एक तो ऐसे आएगा, so if it's k naught equal to 4 for example 6 for example 0.2, so you can in principle जो graphically है ना, आप जैसे Gaussian function है, there are different Poisson functions हैं, so how we can represent any function उसका। अब यहाँ हमारे पास फंक्शन है वेव पैकेट का स्प्रेड, वेव पैकेट का स्प्रेड जो हम यहाँ what we are going to say is that it is similar to this figure which we are going to explain, that this symmetric distribution of kx about mean value of kx bar। So हम एक वेरिएबल चेंज करेंगे, we are going to write u in terms of kx minus kx bar, ठीक है। u को लिखेंगे in terms of kx minus, यहाँ पर kx को हम लिखेंगे अब जो kx है, kx will be equal to u plus kx bar। So we are going to we are going to see this ku as a function of difference of these two values, उसको हम सबस्टिट्यूट करेंगे यहाँ पर। So जो हमारे पास जो phi है, because this is phi and psi, phi है propagation phi in terms of wave function psi को हम कैसे प्लॉट करेंगे ग्राफिकली। So we'll do further change, हमने kx को ऐसे डिफाइन किया as a mean of this difference। Later we'll see how we can see writing them in terms of expectation values, that comes later। फिलहाल आप यहाँ we are defining things like this. So if you define them like this, so ये function जो हमारे पास आएगा psi x0, it will be, so ये है ना e to the power kx के बदले हम लिखेंगे u plus e to the power kx, तो एक kx आएगा यहाँ पर, it will be kx bar k bar x phi of u plus, sorry, this one I was supposed to put here, this one phi of kx के बदले u plus kx, तो ये आएगा हमारे पास e to the power iota ux, ये kx है हमारे पास, kx के बदले हमने लिखा दिस u minus u plus kx, ये u अपना यहाँ पर है, e to the power kx को हमने ये बाहर लाया, so we can write it like this also. अब मकसद हमारा ये कहने का है कि that this entire जो हमारे पास ये है the relationship of delta x into delta kx will be equivalent to 1. So later we will see that it's basically a statement of uncertainty principle. P delta p into delta q is greater than, so we'll not say it that way. We are going to see that we are going to write this propagation vector k, and this is x, it's the distance where this wave spread is. How this conjugate का हम कैसे plot करेंगे? If we define u in terms of k minus kx, some mean value, ठीक है? That will correspond to this conjugate relationship, which will not say ये uncertainty relation है, so it will have this sort of this relationship, such that जो हमारे पास जैसे इसका मीन है ना, मीन ऑफ दिस वैल्यू will be minus x delta kx by 2 plus x delta k by 2, मतलब इसका मीन आएगा ना, डिवाइड बाय 2, इट्स, so the function will have from this to this. अब ये इसमें दो पॉसिबिलिटीज बनती हैं, इसमें दो पॉसिबिलिटीज बनती है, x naught delta k will be greater than 1, so then this will go from kx by 2 to delta kx by 2. So अब इसमें दो पॉसिबिलिटी बनती है, this is greater than 1 or this can be less than 1. So if it is greater than 1, so once that wave spread is going on, basically it's superposition of that wave which has started from x0 and t. हम कहते हैं where probability spread is maximum. Probability of maximum आने से पहले, जिस तरह यहाँ पर इन क्लास के लिए हमारे पास आते थे नोड एंटीनोड, ठीक है? So what is the peculiar combination where if the wave is between k plus delta k and k minus delta k, which we have defined it in terms of this kx, and where it can be maximum, it can be minimum around some mean function ये जो हमारे पास यहाँ पर अगर maximum है इस साइड और इस साइड, so for अगर ये greater than 1 है तो it might have many destructive interferences before we are going to have the actual spread, ठीक है? So it's a bit tough idea, it may take some time to उसको क्या कहते हैं आप digest करने में, हजम करने में थोड़ा, just but at least you see it. Basically we are going to show it that it's like that. So further you can write it as दो waves को अगर again if you want to show it, there is another, this is figure 2.1. So if another figure is like this, k नॉट इज हियर, ये 2 है, ये 4 है, 6 8 के एक्स है प्रोपगेशन, दिस इज 5 kx, this is 0.2, 0.4, 0.6. So this is like this how they will represent. So we have defined some maximum spread where it's mean of both sides, where it will k plus delta x है, k minus. तो यहाँ इसका मैक्सिमम स्प्रेड के बाद इसका एवोल्यूशन कैसे आएगा? So if it can be greater than 1 or it can be equal to 1. It will come by and by. For example, if you read the book, there is an example. I'm only stating the stop. The example is that if phi is this, and kx minus delta is equal to is less than kx is less than kx plus delta, and phi x is 0, calculate psi x and plot psi x of 0. So you have to calculate पहले psi x कैसे calculate करेंगे, psi x कैसे calculate psi star, that's square of the modulus, फिर उसको plot करना है. This is basically we are plotting this function. It will come by examples. ठीक है?